What makes a tornado? Last longer than others? A typical tornado lasts about 10 to 15 minutes, but under certain conditions, it can persist for over an hour or even more. The key lies in the storm that creates it, a type of thunderstorm called a supercell. Supercells are the most powerful thunderstorms on Earth. They have a rotating updraft called a mesocyclone, which can sustain itself for long periods if the atmosphere is unstable enough and the wind shear, change in wind speed and direction with height, is strong. If this rotation remains steady and the storm continues to draw in warm, moist air from the surface while expelling cold air aloft, the tornado can last for hours. The longer the supercell remains organized, the longer the tornado can live. The role of wind shear and atmospheric instability. To understand why some tornadoes are long-lived, you have to look at wind shear and instability. Wind shear helps the storm rotate. Instability provides the energy. When warm, humid air from the Gulf of Mexico collides with cold, dry air from Canada, the atmosphere becomes unstable. This is common in the central United States, especially in Tornado Alley, making it a breeding ground for long-lived tornadoes. If the shear is just right, the storm tilts its updraft and keeps drawing new air, recycling energy without choking itself. This can allow a tornado to remain on the ground for dozens or even hundreds of miles. The Tri-State Tornado, the longest lasting in history. The most famous and longest lasting tornado ever recorded was the Tri-State Tornado of March 18, 1925. It ripped through parts of Missouri, Illinois, and Indiana, staying on the ground for 3.5 hours and carving a continuous path for an astonishing 219 miles, 352 kilometers. This tornado remains the deadliest in U.S. history, killing 695 people and injuring more than 2,000. What made it so unique was not just its length, but its consistency. The storm moved at around 60 to 70 miles per hour, incredibly fast for a tornado, and maintained its strength almost the entire time. Scientists believe it was part of a long-track supercell that stayed extremely stable, constantly feeding on warm, moist air from the south. It never lost its rotation or structure, allowing it to remain on the ground far longer than usual. The 2011 super outbreak, long-lived tornadoes across the South. In April 2011, the United States experienced one of the largest tornado outbreaks in modern history. Over 360 tornadoes touched down across multiple states during what became known as the 2011 super outbreak. Among them were several long-track, long-lasting tornadoes. The Hackleburg Phil Campbell EF5 tornado in Alabama stayed on the ground for 132 miles and lasted about 2 hours. The Smithville EF5 tornado, also in Mississippi, was on the ground for nearly 1 hour and traveled over 60 miles. Both tornadoes came from extremely powerful, isolated supercells that developed in perfect atmospheric conditions, massive instability, strong wind shear, and abundant moisture. These storms produced rotation that remained stable for unusually long periods. The 2013 El Reno tornado, a monster that lasted just long enough. The El Reno tornado in Oklahoma, which struck on May 31, 2013, may not have lasted as long as the Tri-State or Hackleburg tornadoes, but it's worth mentioning because of its massive size and unusual behavior. At its peak, it grew to 2.6 miles wide, the widest tornado ever recorded. Although it lasted only 40 minutes, it showed how even a relatively short-lived tornado could produce catastrophic damage. What's fascinating is that the same atmospheric dynamics, powerful wind shear and a rotating supercell, that allow long-lived tornadoes to form also created this monstrous one. Its rapid shifts in direction and speed tragically caught several experienced storm chasers off guard, proving that even short-lived tornadoes can be incredibly dangerous. Why some tornadoes die quickly. Most tornadoes form and fade in a matter of minutes. That's because the conditions that sustain them often collapse quickly. If the updraft weakens, or if cold downdrafts wrap around the tornado and cut off its warm air supply, the tornado's rotation begins to break down. When a storm merges with other cells or moves into a region with less instability, the tornado simply can't survive. Short-lived tornadoes are often weaker, smaller, and form on the edges of storms rather than deep inside them. They might last only a few minutes and cover less than a mile, but they're still dangerous. The role of terrain and geography also plays a big role in how long a tornado lasts. Flat terrain, like the Great Plains of the US, allows storms to move without interruption. Tornadoes in open areas can stay organized for longer because the storm's inflow, the warm, moist air that feeds it, isn't blocked by mountains or rough landscapes. In contrast, in hilly or forested areas, the storm structure can become disrupted. Tornadoes that move into mountainous regions or across large rivers often weaken because the flow of air changes and the updraft loses balance. That's one reason why the longest-lived tornadoes in history tend to occur in flat, open regions like Kansas, Oklahoma, Missouri, and Alabama. Modern tracking and data on long-lived tornadoes. Today, meteorologists use Doppler radar and satellite data to track tornadoes more precisely than ever before. With this technology, scientists can identify long-track tornadoes, those that stay on the ground for at least 25 miles, and study their structure in detail. One discovery is that many long-track tornadoes might actually be families of tornadoes, where one fades and another forms almost immediately from the same supercell. However, some are confirmed to be single, continuous tornadoes, which is extremely rare. The National Weather Service now classifies long-track tornadoes based on both radar and ground damage surveys, ensuring more accurate records. Could we see another tri-state tornado? Many meteorologists believe that a tornado as long-lasting and deadly as the 1925 tri-state tornado could happen again, but it would likely be detected much sooner today. Modern radar systems, storm spotters, and warning systems have dramatically improved. People now receive alerts through phones, sirens, and television long before a tornado arrives. But the right combination of conditions, extreme instability, powerful wind shear, and a stable supercell could still produce another hours-long tornado. Climate change might also influence these patterns. Some studies suggest that warming temperatures could shift tornado activity farther east into more populated areas, potentially making future long-lived tornadoes even more dangerous. The science behind tornado longevity. At its core, a tornado's lifespan depends on the balance between inflow and outflow. Inflow brings in warm, moist air, the tornado's fuel. Outflow pushes cooler air outward. If these two remain balanced, the rotation can persist for hours. But if the outflow overwhelms the inflow, the tornado starves and collapses. Long-lived tornadoes tend to occur in storms where this balance remains nearly perfect for extended periods, something that's incredibly rare. It's a fine-tuned dance between temperature, humidity, and wind dynamics that only happens under very specific conditions. The human side, stories of endurance and survival beyond the science, long-lasting tornadoes leave behind unforgettable human stories. Survivors of the tri-state tornado described hearing a constant deafening roar for hours as the storm passed through town after town. Many never saw the funnel, just a black wall of debris. During the 2011 super outbreak, people in Alabama and Mississippi saw multiple long-track tornadoes on the same day, each lasting more than an hour. Some families lost entire neighborhoods, while others narrowly escaped. These storms remind us that long-lived tornadoes aren't just meteorological marvels. They're human tragedies that test resilience and unity.